Hi everyone, I'm Sam, the team lead from ProEats. Today we are thrilled to present you with our project, and we will be covering 3 parts. Today we'll be covering 3 parts in this presentation. First, I will show you a demo video. This is the same video in the brochure for today's showcase. Since you probably have seen it, made it shorter and the pace will be really fast. And I will stop halfway and talk you through the rest of our stacks and architecture. And in case you want to watch the entire video, there's a link in the brochure, and you can find it also on the board to your left-hand side. So let's get into it.
Hi everyone, I'm Sam from ProEats. As a foodie, one of my favorite things is to eat out and discover new restaurants. And today, I'm gonna show you how to eat like a pro with ProEats. This is how it works. Open ProEats website. You will see a collection of featured restaurants sorted by cuisine and rating. Also, you can search for stage, party size, and cuisine to get a list of restaurants that best match your needs and filter through them to find the ideal one. Dive into one of the top-rated restaurants. The clean and simple design makes it easy to read through all their info and reviews. You can zoom in and out on the map to see the exact location of the restaurant. On the booking section, select your party size, preferred date, and time to find out all their seating options. To make a reservation, you must sign in or sign up if you don't have an account. You must also provide the correct email and password. After you sign in, the information will be pre-filled. Simply fill the rest and make the reservation. You will receive a confirmation email within seconds. And there you go. You have secured a table for your party ahead of time. In your profile page, you can see all your upcoming and past reservations, alongside your saved restaurants and account info. You can cancel a reservation at any time. Once your reservation has been completed, you can leave a review, rate your experience, write some comments, use a nickname if you feel more comfortable. You can only submit 1 review per reservation. If you really enjoy the experience, you can save the restaurant for easier access, and you can find your review on the restaurant page. For our business partners, go to the bottom of the page and log in to see your dashboard. Managing your reservation has never been easier. You can see all the details in the reservation section. You can complete or cancel the reservation with a simple click. If you wonder who built this amazing website, we are a team of 13, including 8 developers, 4 DevOps, and 1 business analyst. We implemented the Agile methodology in our daily development. Here are some of the stacks we use in our front-end and back-end.
So I will stop here and come back for our technical stacks. So for our front end, we use the basic 3, JavaScript, CSS, and HTML with React framework. We use Redux toolkit to shorten the development process instead of the traditional Redux because it has too much boilerplate to set up. We also know we know how to use it, but there is a better way to increase our productivity. So why not? For our styles, we started with Sass and Material UI. And later on, we introduced the style component because of the style pollution to prevent that. And we also used the Pixie.js for our flow map visualization, which is not fully developed. Here's a screenshot of it. And the idea is that the restaurant owner, they can draw their own flow map and assign the reservation to each table. We also use the Jest and TypeScript for both front end and back end to test and prevent errors. And it does take a lot of time to figure out the types at first. And sometimes it's really time consuming and frustrating to do so. But when you get used to it, it's really worth the time. For our backend, we implemented the REST API in Node environment with Express. We used SendGrid for sending the confirmation email. And finally, we use MongoDB as our database with Mongoose library to handle data manipulation. That's pretty much all about the stacks and why we choose them. Now, let's hear from our DevOps Vivian to tell you more about our architecture.
Hi, everyone. This is Vivian. I will introduce the architecture of this project. In this project, we use the three-tier architecture, consists of the presentation layer, business logic layer, and the data storage layer. Let's look at the presentation layer first. For the presentation layer, we configure the AWS S3 and CloudFront. The Route 53 is used to manage the domain name and route users to the app. We use S3 bucket to host our React static website as the front-end solution. We use CloudFront to configure CDN for loading page, which decrease the latency to deliver contents to the users. We also register the SSL certificate on AWS Certificate Manager to improve user experience. For the logic layer, our application is implemented as ECS Fargate tasks in two different availability zones, which provides high availability and deployed in private subnets for secure communication. The private subnet does not have direct access to the internet. Therefore, we attached two NAT gateways in public subnets to solve this problem. The NAT gateway can talk to the internet on behalf of the ECS so that the tasks are able to request the ECR images or send logs to the CloudWatch. Then we deploy the application load balancer to allow traffic from public to reach our containers so that users can access the ECS through application load balancer and forward the request traffic to the container tasks. Each Fargate task is attached to an elastic networking interface. Then the IP of the networking interface is added to the load balancer configuration. This architecture allows our application container to be safely isolated from the rest of the internet. They can initiate communication with external resources through NAT gateways and still be able to receive traffic from the public through application load balancer. For the pictures uploading feature, we use Lambda function and API gateway to implement. API gateway can provide a secure and a scalable gateway for web APIs that route HTTP requests to Lambda function. The use of Lambda function benefits from the serverless architecture, which reduces the problem of server latency. The data storage layer was implemented using MongoDB. Our project used CloudWatch and Grafana for monitoring and alerting. The application load balancer and Fargate sent logs to CloudWatch and then imported into Grafana. Next, I will talk more about the CI/CD pipeline of this project. So the Bitbucket pipeline is used for both front and back. Pipeline will be triggered when the code is merged to the main branch. Then the Bitbucket pipeline will look for this YAML file to execute the pipeline steps. For the front end, after the pipeline is successfully installed and built, the build artifacts will be uploaded and deployed to the AWS S3 bucket. And then the CloudFront will be set up to deliver the web contents to the users. For the backend, the pipeline will first install the packages, Dockerize the backend, and then push the images to ECR. The ECS Fargate tasks will be created to deploy the backend by using the latest Docker images. Well, that's all about the architecture. And now back to the Sam.
Thanks, Vivian. That would be everything for our presentation. If you're interested, we welcome you to join our private room later. We have prepared another presentation in which you can interact with, and I will be introducing our team members individually, including their responsibility and contributions to this project, so you can get to know them better. Thank you again for your time, and we'll see you later.